Hi there, here are 10 SAT official math questions you must know for a perfect score. The first question is complex number multiplication. We should always have such questions for each year, right? So what's the product of the two terms? Let's do this question together. So we want to expand the brackets, right? We use the first term, number 3 times the second brackets, right? It's 3 minus 6i. And then we use the second term in the first brackets, multiply the second brackets. 4 times I minus 8i squared, right? So we get 3 minus 2i and minus 8i squared, all right? So this is the topic of complex numbers. The second question would be the circle geometry and the chord length. A official SAT math question could be a circle has a radius of 10 and the chord is 8 units from the center. Then how long is the chord? We can draw a circle for this question, right? So a chord is 8 units away from the center and the radius is 10, right? So we would apply the Pythagorean theorem. That is the half chord square plus 8 square equals 10 square, right? So we would solve this equation. Then the half chord length should be positive 6, right? So the length of the chord should be 2 times 6, which is 12. For the third question, which is related to the algebraic identity, the shortcut squared, the question like if 2 times x plus 2 equals 25, then what's the square of 2 plus x plus 2? We would use the known identity and the substitution, right? So we would solve it like this. 2 times x uh, plus 2 equals 25. And then we can solve the value of x, which equals 11.5. And then x plus 2 square would be 30.2 square, which is 182.25. And for the first question, which is related to the trigonometric identity, if sine theta is 3 divided by 5 and theta is in the first quadrant, and then what's the value of cosine theta? So we would apply and use a Pythagorean identity for the classic speed question like this, right? So we know the equation of sine theta squared plus cosine theta squared equals 1 would always satisfy for all the thetas. So we would plug in the sine theta, that is square plus cosine theta squared equals 1, right? And then we know the cosine theta would be positive or negative 4 divided by 5. And we know the theta in the quarter 1. So the cosine theta should be positive. We should choose the first value for the cosine theta. It's 4 divided by 5, right? And for the fifth question, uh, given fx equals 3 times x cubed, then what's the value of f prime of 2, right? We would use power rule for differentiation, which states that if gx equals ax raised to the power of n, then we know the the g prime of x would equals n times a times x raised to the power of n minus 1, right? So we can then solve the f prime of x in this equation, right? Which equals 3 times 3x squared, right? And minus 4, right? And then we plug the number 2 into our function, that is 3 times 3 times 2 squared minus 4, right? And then answer would be 32. All right, so we should just apply the straightforward differentiation and solve it. For the sixth question, we want to solve for x if 3 raised to the power of 2x minus 1 equals 27, right? For such question, we should recognize and should be very familiar about the rule that 27 equals 3 raised to the power of 3, right? That is 3 cubed, right? So, and then we would know that 2x minus 1 would be equal 3, right? And then we solve for the value of x, which is number 2, right? We should be quite familiar about such rules, other similar rules, such as 8 equals 2 cubed, right? And for 4 cubed, what's the value of this one, right? It's 196. And for 5 cubed, it is 225, right? We should be familiar and memorize such rules. And for the question 7, if log x equals 5, then what's the value of x? Then we just translate to the exponential, right? So log x equals 5. Since here log just means 10, so x would equals 10 raised to the power of 5, right? So for the question 8, we would deal with absolute value equations, such as if 8 minus 5k absolute value equals 6 plus 3, then what's the value of k, right? So we would solve this question for two cases. That is, for the first cases, 5 minus 8 minus 5k equals 6k plus 3, right? And for the second case, that is negative 8 minus 5k equals 6k plus 3, right? For the first case, we can solve the value of k, which is 1. And for the second case, the k equals negative 11, right? For the question 9, a circle of radius 5 has a increased square, then what's the area of the square? Right? We can just have a figure for solving the problem, right? And we know the radius is 5. And what's the area of the square, right? Then we want to know the value of the side of the, the square, right? So this one is 5, and we know this one, this value, this radius is also 5. So based on the rule, that is the side would equals 5 equal times the square root of 2. That is based on the rule that 5 square plus 5 square equals the side square, right? So based on this rule, we can calculate the value of the side, and so the area would equals, 50, right? So it's quite simple if we just get a figure of the problem, which is very useful for the problem solving, right? And for the most difficult questions in SAT Math, it would be involves multiple step manipulation of the equations, and it will involves other issues like trigonometry, right? We would discuss such the topics in my future videos. All right, guys, thank you, and please leave me a message if you have any questions. Thank you. Bye bye.